Hi, everyone. In Chapter 0, we introduced this idea that we're going to approach statistics a little bit differently than you might in a traditional course. In this chapter, we're going to focus on how stats fits into the larger research process. That includes the idea of a literature review, trying to understand the kind of evidence that you're going to need if you're going to do a study. In this case, we're going to use the stress process as the basis for understanding the things that impact people's depression. We're also going to talk about this idea of observational research versus experimental. And I want you to know when I use the word observation, this and many other books that you look at, they want to focus on the idea of collecting data in the real world as opposed to doing laboratory experiments. So observational research can include qualitative studies, but also in the case of this course, it's going to be much more about collecting survey data as opposed to experimental data. Finally, we are going to focus this week on getting to know our data. Our mantra is that statistics is about people. So your goal is to get to know your data set, which means you're going to get to know your people a little bit better before you start performing any statistics. So let's get started.
At the start of this course, I want you to think about statistics not as a collection of formulas, but as a way of investigating real social questions. This semester, we are treating statistics like a detective treats evidence. Our central mystery is straightforward but deeply important. Why do some college students experience depression while others do not? Many people have strong beliefs about what causes depression, but personal experience alone is not enough to evaluate complex social patterns. Statistics allow us to compare groups systematically, measure uncertainty, and avoid being misled by isolated examples. By the end of the course, you should feel comfortable reading data as evidence and using it to make careful, defensible claims about the social world. You may even learn something about yourself along the way. Scientific inquiry follows a recognizable logic, regardless of discipline. The process begins with a question. From there, investigators gather evidence, consider multiple explanations, and draw conclusions based on how well the evidence supports each possibility. One key idea is that data never exist in isolation. Evidence must always be interpreted in context. Knowing who was studied, what was measured, and how information was collected is essential for understanding what conclusions are reasonable. Learning to recognize these limits is part of becoming a careful consumer of research. Theoretical models are simplified representations of how we think the social world works. They help us organize complex information and clarify which relationships we want to examine. Throughout the semester, we will use theoretical models to guide our analysis, but we will also test those models against data. To keep our investigation organized, we rely on a 5-step research process that structures the entire course. The first step is asking a meaningful question. A good research question is clear, focused, and grounded in real social concerns. In our case, the question about depression among college students provides a concrete outcome we can measure and explain. The second step is gathering evidence, which involves deciding what data are needed and how they should be collected. The third step is describing the evidence. Before attempting to explain anything, researchers must understand what their data look like. This includes summarizing who is in the sample and examining how key variables are distributed. Descriptive statistics serve this purpose and often reveal patterns worth exploring further. The fourth step involves testing explanations. Here, we compare groups and examine relationships between variables to see which explanations are supported by the data. The final step is drawing conclusions. This does not mean declaring absolute truth, but rather identifying which explanations are most consistent with the available evidence. Importantly, these steps are connected. Weak questions lead to weak evidence, and poor descriptions can undermine later analyses. By following this process carefully, we ensure that each conclusion we reach is grounded in a clear chain of reasoning, from question to evidence to explanation. One of the most important ideas in this chapter is that science does not produce certainty. Instead, scientific knowledge is always provisional. Using capital D data allows us to improve our understanding of lowercase t truth, meaning our best current explanation of how the world works. Even the strongest conclusions remain open to revision if better evidence or methods become available. Statistics play a crucial role in this process because they help us measure uncertainty rather than eliminate it. When we analyze data, we are making inductive inferences, which means there is always a possibility that our conclusion could be wrong. This perspective should be reassuring. It means that science is not about being right forever, but about improving explanations over time. New studies refine, challenge, or extend earlier work. Rather than starting from scratch, researchers build on what others have already discovered. This is why published studies begin with a literature review. This process helps refine research questions and avoid unnecessary duplication. In this course, we rely on Len Perlin's stress process model as a theoretical guide. This model proposes that mental health outcomes like depression are shaped by the interaction of social background characteristics, exposure to stressors, and access to personal and social resources such as self-esteem and social support. The model helps organize our thinking about which variables matter and how they might be related. Importantly, using theory does not mean accepting it uncritically. Our task is to test how well theoretical expectations align with data. By comparing multiple explanations within a shared framework, researchers can identify which mechanisms are most consistent with observed patterns. Once researchers have a question and theoretical framework, they must decide how to study it. This involves selecting a research design and determining how key concepts will be measured. In our investigation, surveys are particularly useful because they allow us to collect information on many characteristics from a large group of students using consistent questions. Measurement is a critical step in this process. Concepts such as stress, depression, and social support are abstract ideas that cannot be observed directly. Researchers must translate them into variables by designing survey questions or scales that capture specific aspects of these experiences. Throughout the semester, we will examine how different variables were measured in our dataset and consider the strengths and limitations of those measurements. Understanding how evidence is constructed helps you evaluate what conclusions the data can reasonably support and where caution is warranted. Before any statistical analysis can begin, researchers must prepare their data. Data preparation includes checking for errors, handling missing values, and ensuring that variables are coded consistently. Without this work, statistical results can be misleading or incorrect. A key principle is tidy data organization. In tidy data sets, each row represents a case, each column represents a variable, and each cell contains one valid value. This structure makes it easier to analyze data and reduces the risk of confusion. Researchers may also recode variables to improve clarity or conceptual accuracy and transform variables to address skewed distributions. Although the datasets used in this course have already been prepared, understanding these steps is important for interpreting results. Well-organized data form the foundation of credible analysis. Without careful preparation, even sophisticated statistical techniques cannot produce meaningful conclusions. Once data are prepared, the first analytical step is description. Descriptive statistics summarize key features of the dataset and help researchers become familiar with the evidence. Frequency tables show how cases are distributed across categories, while graphs such as histograms reveal patterns in numerical variables. Describing the evidence serves several purposes. It tells us who is represented in the study, highlights potential anomalies, and often suggests questions for further investigation. For example, observing variation in depression scores raises questions about what factors might explain those differences. Importantly, descriptive statistics do not explain why patterns exist. They provide the foundation for explanation by ensuring that researchers understand what the data show before moving on to more complex analyses. Skipping this step increases the risk of misinterpretation and flawed conclusions. One goal of this course is to help you become comfortable reading statistical output from different software packages. Although we will primarily use Excel to perform our analyses, you will encounter SPSS, Stata, R, and other software in journal articles, graduate school, or the workplace. Notice that these two tables describe essentially the same information. The labels differ, but the purpose is identical. Summarize how respondents are distributed across categories. The SPSS output includes two additional pieces of information. Valid percent excludes respondents who skip the question, while cumulative percent provides a running total across categories. When there are no missing responses, percent and valid percent are identical. When missing responses exist, however, valid percent is usually the value researchers report because it reflects only those who actually answered the question. The important lesson is not memorizing software output. The important lesson is learning to ask, how are these percentages calculated? Here we see an example where 2 people out of 100 did not respond to the question about sex category. The denominator is now 98. So, now we only have 56 females and 42 males, and to obtain their percent in the data, we divide 56 over 98, not 100, or 57.1%, and 42 over 98, which is 42.9% in valid percent. After describing the evidence, the next step is explanation. Explanation involves identifying factors that are related to the outcome of interest and evaluating how strongly they are associated. In social research, this almost always requires comparing variables rather than examining them in isolation. Human behavior is shaped by multiple interacting influences. Depression, for example, may be affected by stress, self-esteem, social support, and background characteristics simultaneously. Statistical methods allow researchers to examine these relationships systematically and assess which factors remain important when others are taken into account. Throughout the remainder of the course, we will move gradually from simple comparisons to more complex models. The goal is not to find a single cause, but to build a nuanced explanation that reflects the complexity of social life while remaining grounded in evidence. Social scientists rely on both observational and experimental research designs, each with distinct strengths. Observational studies involve collecting data from naturally occurring situations without manipulating conditions. Surveys and qualitative interviews are common examples. In this class, we will focus on survey research data because it is in numerical form. Experimental studies, in contrast, involve manipulating one or more conditions and randomly assigning participants to groups. This design strengthens causal inference, but is often impractical or unethical for many social questions. For instance, researchers cannot randomly assign students to experience stressful life events. Because of these constraints, much of sociology relies on observational data combined with statistical methods that help disentangle competing explanations. Understanding the strengths and limits of each design is essential for interpreting research findings responsibly. This chapter establishes the foundation for our investigation. We have learned how sociological research begins with meaningful questions, builds on prior knowledge, gathers and prepares evidence, and uses descriptive statistics as a first step toward explanation. Each of these components is necessary for producing credible and informative results. At this point, we have identified possible explanations for differences in depression among college students, but we have not yet tested them. That work lies ahead. In the next chapter, we will begin examining the students in our dataset more closely and producing our first descriptive summaries. As the course progresses, each new statistical method will add another piece to our investigative toolkit. By the end, you should be able to evaluate evidence, assess competing explanations, and communicate findings clearly using quantitative reasoning. As we finish this first chapter, I'd like you to think beyond grades and assignments. The skills you develop in this course will help you evaluate research, interpret information presented in the media, and make better decisions based on evidence rather than intuition. Throughout the semester, we'll continue investigating our central question about depression among college students. Each new statistical technique will provide another tool for examining the evidence and evaluating competing explanations. By December, I hope you won't simply know how to produce a frequency table or calculate a statistic. I hope you'll have developed a new way of thinking, one that values evidence, recognizes uncertainty, and is willing to follow the data wherever they lead. If you leave this course thinking like an investigator, then I will consider this semester a success.